Good evening, my dear NEET 2026 aspirant, the class 12th, first chapter, first topic electrostatic charges, electrostatic forces, and fields. That's your chapter 1 of NCRT from 12th standard, part 1. And we're going to start it off today. Today is the day where you begin the journey officially on YouTube. And daily classes, like we have told, like I have announced already, 6 o'clock 11th standard, 8 o'clock 12th standard. The 11th standard class is around 1.5 hours, and 12th standard classes again almost same time, if needed 2 hours, 2.5 hours, because there is no class after 10 o'clock, right? So good evening, nice to see our new students. Hi Paki, Nandu, Jesse, Blessy, Radha, welcome. I'm very good. Thank you so much. Good evening. Good evening. Ananti, hi aspirant. Hi everyone. Welcome aboard Money. And it's so nice to see all new students out here, because I know our old students, most likely 99% of them are going to get some seat. They're just waiting for the result day of NEET 2025, and they are going to book a seat. Next year, it will be your turn. So, my dear students, make a promise to yourself that you are going to crack it. You are going to attend every single day live. Don't miss any class, because we are going to be very regular over here, and not many channels are doing 2027 content or class 11th content. So we are doing that also, and we have kept the timings also separate. So make sure you're watching both the classes and you complete the syllabus, because equal weightage is there in your NEET examination. So a little bit about me, because a lot of you are new. So my name is Shreyas. You can call me Captain Shreyas, and I have been training, teaching, guiding, mentoring for a long time now. I started my journey more than 13 years back as a teacher in offline, and after producing some amazing results, that's where I got a lot of confidence, and I thought I should do more, and that's why I'm here also on YouTube, so that you know maximum number of students can learn under me. All right. So I want to make sure that every student preparing for any competitive exam has the best content, best teacher in English for physics subject, right? So I did my graduation in NIT Nagpur, and after that did my research in IIT Bombay, and cleared my JEE in 2005 with almost full marks in physics. So that's my short intro. If you are new, please let me know about yourself in the chat box right away, right now, or even in the comment section if you're watching it recorded. And like I've told before, your Guru Dakshina is needed for every class. By liking this video, please do that. And if you have not yet subscribed to the #1 NEET English channel, please do that as well. Okay. Hi, everyone. Captain the chat, I mean, not chat. Okay. Linzen, whatever it is, I'll definitely help you out. You put the comments, whatever it is, in the chat box. Okay. So there we go. The Gopika ma'am just had a class, and I saw you guys responded really well. I really appreciate that. Keep it up, and I want you to maintain that same enthusiasm. So many of you are in class 12th or taking a drop. Wow, a lot of class 12 students. Very good, very good, very good, very good. Keep it up. Yes, Capto the Physics King is here. And by the way, many of you were also asking, do we have any offline centers? We do have a lot of offline centers. You can see the link is there in the description box, explore our offline centers, and you can book a visit using this particular link. Enter your name, just book an appointment. I mean, a lot of cities are there in this. In fact, I have mentioned that, I think, in the slides also, where you have the best teachers in a digital classroom. You get the class recordings, digital notes, and plus you have library facility, doubt counters, academic mentors, personal teachers. Even after the class, you can ask doubts via doubt app. So all the things with the books, everything you get, all the centers are mentioned over here, right from Tamil Nadu, Andhra, Telangana, Maharashtra, Punjab, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, and Uttar Pradesh. The Bangalore center, the new one in JP Nagar, we had a visit. Some of you probably might have come there also. So it's a new center in JP Nagar. To pay a visit, guys, and would be really excited and happy to see all of you, from one of these centers as well. Let's paint it all, Vedantu throughout India. Already we are, spreading across, and we make sure that whatever centers we open, we have the best teachers in town at that place with all the required facilities, and then only open. Or else We can open it everywhere, but that's not the point, right? So there are also scholarship tests when you want to take up any batches or anything. So up to 90% scholarship is there when you write the IV SAT exam. So you can visit the center, book a demo, and make sure you write the test, and maybe you get a good discount. Maybe 90% gets off. Who knows, right? So I mentioned it all. So let's begin, guys. Right? All right. If you have not studied anything in 12th, can I study from here? Yes, 100%. Oh, oh, you already are in the Vedantu offline center and no regrets. Wow, that's so cool, Pecky. Amazing, amazing. Nice to see. Which center are you in? All right. So uh, to start off with this concept of electric charges, see, guys, there are things around us which are made up of tiny particles, which are nothing but atoms. Atoms. Everything around us is made of, be it gas, be it liquid, be it solid. They are all made up of atoms. But atoms themselves are made up of teeny mini particles. At the center of the atom, you have a dense object which is called the nucleus. The nucleus has a neutral particle which is called a neutron, and then there is a particle called as proton inside the nucleus, the red ones. They are positively charged. This value of positive and negative is just by convention for historical reasons. We just choose something as plus, something as minus. So protons are those particles which carry something called as a positive charge. And around the nucleus, in orbits, you have these electrons, which are very small mass, which are revolving. Those are negatively charged. Long time back, hundreds of years back, people realized that there are certain bodies which miraculously attract to each other and miraculously repel with each other. Like, for example, you take a comb, plastic comb, and rub on your hair, and then you realize that it can attract bits and pieces of paper. It's not gravity. Also, you take a rod and rub it on a silk cloth, or you take another rod and you rub it on a woolen cloth. You will see that the rods develop something called as a charge, and those rods can then either attract or repel each other depending on the type of the charge on it. So these charges are those scalar quantities. Scalar means those things which just have a value. They don't have any direction. Like when I say the nucleus has positive charge, electrons which are revolving have a negative charge. That negativeness, that positiveness does not have direction. It only has a number, value. So that is why I call them scalars. So the charge is a property of a body. It is a scalar property of a body which tells you, how much is it charged, and whether it is positive or negative decides whether it is going to attract and repel each other. Okay. So the electric charge is an intrinsic property. Intrinsic property. Now, what is the meaning of intrinsic? Of matter. Of matter. Intrinsic means your internal. Like, for example, you as a person have some weight, some height, some waist size, some size of your arms, size of your legs, whatever. So those are your internal, intrinsic. The moment you exist, you have a weight. Obviously, you have some height. It is automatic. It is a part of you. It is internally already there by default. It is like your default setting. So it is an intrinsic property of matter. It is an intrinsic property of matter. And they are of three types. 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 What are those types? Number one, as you can see over here, one is negative. Number two, as you can see over here, positive. And the third one, basically, there is no charge, basically zero, or sometimes also called as neutral. These are the only possibilities. Is this absolutely clear? Okay, everyone with me? Example of a negative charge, already mentioned electron. Example of a positive charge, already mentioned proton over there. Zero, neutral. Example, neutron. Neutron. Now, it is also very important for you to understand, if you have a negative charge, if you have, say for example, a negative charge placed beside another negative charge, or a negative charge placed beside a positive charge, or a positive charge placed beside another positive charge, how their behavior is, well, if you have opposite charges, they will definitely attract each other. They will definitely attract each other. But you have like charges, similar charges, negative, negative, positive, positive, they will end up repelling each other. That is a standard. Opposite charges will attract, like charges will repel. Like charges, similar charges will repel, opposite charges will attract. But what will a neutral charge do? A neutral charge, zero, or a neutral charge will not apply any force, will not apply any kind of force on any body. Okay, it is neutral, no charge at all. So it will not pull or push, attract or repel anything. As simple as that. Everybody fine till this point? Absolutely clear? Okay. Now, this particular charge, like I mentioned before, it is a scalar quantity. It is a scalar quantity. The unit of it, I will mention the SI unit, the SI unit of charge. What is the SI unit of charge? It is Coulomb. It is basically Coulomb. Short form is capital C, and the symbol of charge usually is small q or capital Q. Usually you use small q or capital Q, which is a symbol of charge. But neutral will also attract? No. So if it is a pure neutron, it cannot attract or repel anything. But if there is a body which is made of some positive and negative charges, those positive and negative charges inside of it will attract and repel. But the body as a whole will not, I mean, if it is a neutral particle itself, no charge on it, then it will neither attract nor repel, Parki. Okay, I hope this is absolutely clear. So when I say neutral or zero over here, there is no charge only at all. It's not like positive and negative is there in equal amounts. I'm meaning no charge only on that body. Absolutely. Okay. Now these charges do have some property, but before going to those properties, let's understand what do I mean by a positively charged body and a negatively charged body. So say for example, okay, same thing we'll say. If there is a body over here, then there is another body over here, then there is another body over here, and then there is another body over here. Okay, and now let's take some values. Let's say, for example, there is some negative charge, negative charge, negative charge, negative charge. Here also negative charge, negative charge. I hope you are able to see it. If you are not able to see it, I will show it in some different color. Negative, 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 negative. Okay. Then we'll show the positive charge also, just like you had positive charges. That also I'll show. Imagine positive, 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 positive. Here, positive, 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 positive. Okay. Positive, positive. Okay. And positive. All right. Now consider all these bodies and Let's understand which one of them is positively charged, which one of them is negatively charged, which one of them is not charged, which one of them is neutral. In the first body, as you can see, there is no charge only. There is no positive, there is no negative only. It's made up of maybe only neutrons, like a bunch of grapes. All those grapes are no charged, neutral bodies. So this is not charged at all. Not charged at all. And it is neutral. And it is completely neutral. Everybody agrees with this? It is completely neutral. In this particular body, you can see amount of positivity and negativity is same. This is also considered to be neutral. This is also considered to be neutral. But there is equal amounts, equal amount, equal amounts of positive and negative charges, which cancel each other, which cancel each other out. So this is also neutral. Even this is also neutral, but this has no charges only, or I will say there are no charges only at all. So there are no charges at all. There are no charges at all in this, and yet it is neutral. Here there are charges, but it is neutral because positivity and negativity is the same. Okay, fair enough till this point. Now look at this particular body. Can you see there are more positives than the negatives? So when the positives exceed the negatives, then you say the body is positively charged. Positively, positively charged. It is said to be positively charged. Is this clear? Absolutely. Why it is positively charged? Because the positives are more than the negative. How much ever is the excess is the charge on the body. So if somebody asks you what is the charge on the body, the charge on the particular body, it is always the excess which is there. In this scenario, can you guess what is that excess? This negative positive cancel, this negative positive cancel. 1, 3 extra positives. So this has positive 3 charge, or basically plus 3 as a charge. Everybody agrees with this? Why positive 3? 1, 2, and 3, because other two positives are getting cancelled and nullified by the negative. Very good. Now coming back over here, count the negatives 1, 2, 3, 4, 5, 6. Positives 1, 2, 3. Oh, so the negatives are dominating. So this is said to be negatively charged. This is said to be negatively charged. This is said to be negatively charged. Okay. If you ask me what is the charge on the body, if you ask me what is the charge on the body, charge on the body, then we can easily tell, well, see, this positive negative cancel, this positive negative cancel, this positive negative cancel, 1, 2, and 3 are remaining. So it has a charge of 1, 2, 3, which is basically minus 3. Minus 3. Is that right? So this pair, and this pair is formed. 1, 2, 3 negatives are remaining. So negative 3 charge is there on it. Very good. Excellent. Perfect till this point. So what is the meaning of a neutral body? It can either have no charge or have equal charges. Negative charge means it has more positive than negative. Sorry, positive charge means more positive than negative. Negative charge means more negative than positive. That's it. That's all it means. It negatively charged does not mean it has only negative. It's just that the negatives are slightly more than the positives. That's all. Now, let's talk about the properties of charges one by one. The first important thing, and that is also a property of a scalar. That is also the property of a scalar quantity. Scalar quantities are those quantities which have only magnitudes, values. You can just add with their and play with their values. You don't have to worry about their directions. Like mass. For example, if I have 2 kg mass and a 5 kg mass, if I bring them together, it will be 7 kg. I don't have to worry, oh, what direction? Not needed. Same thing with charges. For example, if I have, say, charge Q1, if I have charge Q2, if I have charge minus Q3, if I have charge minus Q4, then if I ask you what is the total charge of this particular body, these are the charges, then the total charge of this body will be just the sum of them. So it will be nothing but Q1 plus Q2 plus negative Q3 plus negative Q4. You just have to add their values whether it is positive or negative. So just to give you a simple example, let's say I have 2 coulombs, 5 coulombs, minus 3 coulombs, 0 coulombs, minus 2 coulombs, and 1 coulomb. So what is the total charge? That is the question. What is the total charge? That is the question. Just add these numbers. So it will be 2 plus 5 plus minus 3 plus 0 plus minus 2 plus 1. That's it. So 2 plus 5 is 7, minus 3, 0, nothing. So minus 2 plus 1, guys. What is 7 minus 3? That is nothing but 4. And you have minus 2 plus 1. Minus 2 plus 1 is minus 1. So this will be nothing but 3 coulombs of charge. So the total charge is 3 coulombs. Is that understood, guys? Everyone with me? Perfect. Yeah, very straightforward. Yeah, that's how you can add the charges or subtract the charges as it is. You don't have to worry about the directions, but take the signs also. Don't ignore the signs. Do not ignore the signs. That is the first thing. The next important thing, charge as a whole in a confined system, in an isolated system. Isolated means nothing can go out, nothing can come in, like a strict teacher in an offline batch. In online, in YouTube, you can exit, you can enter, you can close the windows, you can close your laptop, you can exit, you can enter at any time. But in an offline batch, teacher says no. After 8 o'clock, no entry, means no entry. Ma'am, can I drink water? Sir, can I go to the toilet? Hey, Poda, sit in the class. Go back to your seat. No exit, no entry. Isolated. Till the class is over, isolated. Nobody goes out, nobody goes in. Simple. Same thing, isolated system means no charge can escape or enter from outside. There is no disturbance. So that in that scenario, the total charge is conserved. What is the meaning of conserved? Let's say Shreyas Sir, in his pocket, he has 5 chocolates. Tomorrow, I put my hand in the pocket and I see only 4 chocolates. One chocolate is missing. So the chocolates is not conserved. Then again, next day I put the hand in my pockets, I see 2 new chocolates. I see 6 chocolates. So the number of chocolates in my pocket, every day it is changing. Somebody is maybe somehow either taking it out or adding. So the number of chocolates is not conserved. But every day I say, oh, there are 5 chocolates, 5 chocolates, 5 chocolates, 5 chocolates, 5 chocolates. It is conserved. It is constant. It is same. So when I say the charge is conserved in an isolated system means if you have a system where the charges can't escape in or out, the total charge will remain the same. Okay. So basically the total charge the total charge of an isolated system remains same. That is the meaning of this phrase, conservation of electric charge. Now look at this. There is a rod over here. Can you see negative 10? There are 10 negative charges. You touch this body. What happened? This became negative 10. This negative 10 became minus 7. So you might be wondering, sir, where did those other 3 negative charges go? You can see it over here. So those 3 negative charges must be over here. So that negative 3 must be on this particular body. Is this absolutely clear, my dear students? So that total charge will remain 100% conserved. I can give you more examples of this. Say, one more example. There is a sphere here which has plus 7 or let's say plus 6 charge. There is another sphere over here which has minus 3 charge. Now you basically touch them. You basically touch these spheres and then you find after some time and you separate them out, this has a charge of plus 8. Can you guess what should be the charge on the other sphere? Can you guess what should be the charge on the other sphere? Come on, my dear students. Everybody quickly answer in the chat box. Everybody quickly answer in the chat box. So I want to know what is this charge over here on this particular sphere. The total charge has to be conserved, meaning the original charge would be 6 minus 3. 6 plus negative 3 is 6 minus 3. Final charge must be 8 plus whatever that question mark is. As you can see, that question mark will be 6 minus 3. 6 minus 3 will be there as it is. And even that 8 will go on to the other side. Even that 8 will go on to the other side. So it will become negative 8. So what is 6 minus 3, my dear students? So what is 6 minus 3? What is 6 minus 3? It is nothing but 3 only, everyone. So what is 3 minus 8? What is 3 minus 8? It is minus 5. So the answer for this is negative 5 amount of charge. Very good. Excellent. So this is what is basically conservation of charge. NEET 2027 aspirant can watch this, but there will be a lot of things like vectors and force, Newton's laws. If you do not know them, maybe you will find some difficulty in the future. Also, the concept of work, power, energy will be there. Okay, everyone, till this point. So this was the total charge before. This was basically what was the charge before, and this was the total charge afterwards. Why did I put an equal to symbol over here? Why did I put an equal to symbol over here? Because of conservation. It should be the same, equal. That's why the before charge is the after charge. So I took that 8 on the other side. 6 minus 3 is 3. 8 is as it is. 3 minus 8 is negative 5. Is this absolutely clear? Pecky, perfect. Yeah. Linson, everyone. 3 plus 8. Okay, which part you did not understand, please let me know right away, right now. Yeah, if you want me to repeat, I will just repeat this. No issues, no issues. See, there was two bodies, one had plus 6 charge, one had negative 3 charge. You touch them and separate them. Somehow this got plus 8. You don't worry about why it got plus 8. That is not our concern. That is none of our concern. This somehow got plus 8. So how much charge should be there on this other body? That was the question. Okay. So what will I say? The total charge must be conserved. So whatever is there before, should be there afterwards. Whatever is there before should be there afterwards. This much part you understand. What is the total charge before, guys? Well, it is 6 plus negative 3. Agree with this? 6 plus the negative 3 charge, which I can also write it as 6 minus 3. Okay, sir, fine. This much I understood. Equal to is as it is. What is the charge afterwards? 8, and I do not know what is this. So it is 8 plus some question mark. I don't know what that question mark is, so I'll leave it as it is. Okay. So if I bring that 8 on this side, it will become minus 8, and this will still remain 6 minus 3, and this will be basically equal to, and this question mark remains as it is. So what is this question mark equal to? 6 minus 3, guys. 6 minus 3 is nothing but 3, and you have basically minus 8. So what is 8 minus 3? 8 minus 3 is 5. So 3 minus 8 will be minus 5. So this should be negative 5. Understood? Step by step I have explained it to you. Okay, perfect, clear, everyone. Now Rahul, Belani, Paki, Linson, oh yeah, clear. Oh, how it got minus 5. Sir, is Vedantu in Tirunelveli? I'm not really sure. Just check the offline form link. In that, all the cities are there. I'm not really sure. Just check it out. Okay. In Tamil Nadu, we are almost there in many places, cities and towns. So maybe around somewhere. Not sure. Okay. So these are the steps that I followed. Okay. Shall we do one example? so that I only feel confident that you have understood it. Okay, come on. I'm going to give you one more tricky example, guys. Okay, ready? Here it is. Before, the charges are on this body, on this body, and on this body. This had +2, this had -1, this had +6. Okay. Afterwards, after some time, they are being touched, and then you release them. You touch these three bodies somehow and you release them, and you find that this body has -2 charge. This body, let's say, has -4 charge. So question is, how much charge is there on this body? Can we solve this together, guys? Come on, let's do this. Okay. Yeah. No, this is not one shot. These are lecture series. One shots marathons will not work for NEET 26 and 27. The paper difficulty is very high. Your attention span is low. Your energy will drop down. Even the teacher teaching will lose energy by the end of the class. So better watch L1, L2, L3, these kind of series. Not many teachers will tell you that. They will find it very easy to go, oh, I have to come and teach only 1 day or 2 days. No, here we are teaching every day, guys. So make sure you are following. Even in what happens in offline or even online batches, every day the teacher comes. It's not like the teacher is coming for 6 hours in an offline center and standing and teaching from morning till night. No, right? Because that is of no use. So there is a reason why your L1, L2, L3, these kind of lectures are going to be helpful for NEET 26 and 27. Got it? Okay. Yeah. So this question which is there, if you don't like that question mark, you can assume this assume as basically some x. No issues. You can assume this as x. So we will put an equal to symbol now, and we will write before charge is equal to the after charge. Before charge is equal to the after charge. What is the charge before? It is a 2 plus -1 plus +6. What is 2 minus 1? It is basically 1, and we have +6 over here. What is 1 plus 6? It is basically 7. Till this point, LHS is clear. Left hand side, 2 minus 1 is 1. 6 is as it is. 1 plus 6 is 7. LHS is clear. Let's look at the right hand side. Here we have -2 plus -4 plus that question mark, or you can write it as x. -2 minus 4, how much is it? -2 minus 4. How much is it, guys? It is nothing but -6 plus x. Oh, so what is x going to be? What is x going to be, guys? Just check this out. This 7 will be as it is. That -6, if I bring it on this side, it will be +6. So what will be the value of x? It will be 13. So this unknown charge will be +13, +13. Everybody understood this? It is +13. Clear? After this, no doubt how to solve questions on conservation of charges. How to solve the questions on conservation of charges. Absolutely clear, my dear students. Perfect. Yeah. Explaining it well. Perfecto. Okay. Let us go, guys. So we have understood till now how charges can be simply added with their signs taken into account. The next property we saw was, the total charge is conserved. Now we solved some example. Let us go to the third important property. Let's go to the third important property. See, guys, I tell you, I have only 500 rupee notes. Only 500 rupee notes. Only 500. Only 500. Nothing else. Tell me, can I ever give you 2000 rupees? Can I ever give you 2000 rupees? Is it possible? Yes, I can give you 500 rupee notes. Definitely possible, right? Because 2000 is 500 multiplied by 4. Perfectly possible. Can I give you 1700 rupees? Is it possible? 1700? No, right? It is not possible. It is not possible. 500 What will you multiply it with? What will you multiply it with to get 1700? No integral. I cannot say, sir, 500, I will cut it in between over here. So it will be some 300 or 200 rupees. No, I cannot do that. Correct. Can I give you 200 rupees somehow? Can I give you 200 rupees somehow? If I have only 500 rupee notes, is it possible? Never ever possible, right? So I can't give you 200 rupees also. Can I give you 8 lakh 75,000 500 rupees? Is this possible? 8 lakh 75,500 rupees. Is this possible? Is this possible, guys? Is this possible? Yes, this is possible. Definitely it is possible. It is a multiple of 500 because I can see it is 8,75,500. So 500 is coming in the end. So somehow I can arrange 500, 500 big bundle of notes I can get. Correct? Yes. Understood? Okay. So why am I giving this example? It was found that the charges can't exist in any quantity. It was found that charges will not be there in any number. You cannot say, I will get this many coulombs. No, charges are always multiples of some number. This property is called quantization of charge. Like the money that I had was quantized, and the quanta of money was 500 in my example, in my world, in that example which I gave. Correct? I can never get 200 rupees, 1700 rupees. The quanta of money for my example was 500 rupees. So same way, the smallest quanta is nothing but the quanta of charge, the quanta of charge, which is the smallest denomination, the smallest value of charge is nothing but plus or minus, anything you can use, 1.6 because positive and negative, 10 to the power minus 19 coulomb. This is the smallest value of the charge. This particular number that you see over here, 1.6 into 10 to the power minus 19, this number has a symbol E. So the value of E is basically 1.6 10 to the power minus 19. Anywhere in physics you see the number E, okay, except for that mathematics E is different, that is logarithms and all that, forget that. That symbol E stands for the charge, which is the smallest charge possible, which is 1.6 10 to the power minus 19. In fact, I can also tell you at this point of time that the charge on a on an electron, the charge on an electron, how much it is, guys? Can you guys quickly guess and tell me? It is actually negative E. Negative E. Similarly, if I ask you what is the charge on a proton, the charge on a proton, it is positive E or just E, you can say. Correct? Electron will have negative E and proton will have positive value of E. Makes sense, everyone? Everyone till this point absolutely clear? Yes, sir. Okay. Now, do you know helium atom? Helium. Hydrogen has one proton. Helium, you might have studied this in chemistry. How many protons and how many neutrons does it have? Guys, quickly, can you tell me how many protons and how many neutrons does it have inside the nucleus? Yes, it has two protons and two neutrons, but those two neutrons are neutral. They have no charge at all. So if you ask me, what is the charge of, what is the charge on a helium nucleus, which is at the center of the atom? Two positive charges, two neutral charges. Neutral you ignore. You just have two positive charges. Yes. So can I say it is positive 2e? Positive 2e. Yes, everyone. If I ask you, what is the charge on a lithium nucleus? Lithium nucleus. Can you think and answer? Hydrogen, helium, lithium. That's the periodic table. Hydrogen, helium, lithium, right? Lithium. How many protons are there? Three protons. So if three protons are there, what is the charge on it? It will be plus 3e. Everybody with me? It is going to be positive 3e. Nisha, it will be around 2 hours. Perfect. So, can I say in general, no matter which body you take, always the charge on it will be some number, 1, 2, 3, 4, natural number multiplied by e, but you can have positive or negative both values. Positive or negative both, because positive or negative charge. This n can be basically natural numbers. Natural numbers, or basically you can have it as like 1, 2, 3, 4, etc. Any kind of integral numbers only, not any decimal numbers. Everyone, so this formula is very important. Q is basically n multiplied by E, where n is the number of charges, E is the charge of the smallest value, and which is also called as the quanta. Q is the total charge on that body. Perfect. Q is equal to Ne. This is called as quantization of electric charge. So let me give you some examples and you tell me whether this charge is possible or not possible. Is this charge possible or not? That is what you need to tell me. The first example 1, 2 into 10 to the power minus 19 Coulomb. Example 2, 4.8 into 10 to the power minus 19 Coulomb. Example 3, 1.6 into 10 to the power minus 20 Coulomb. Example 4, 6 into 10 to the power minus 19 Coulomb. Okay, so, or let's say I'll choose something else. My bad. 8 into 10 to the power minus 15 Coulomb. Okay, perfect. So these are some values. You tell me which one is possible, which one is not possible. Some are possible, some are not possible. So let's see, guys. Come on, think about it. Wherever it is n times of E, it is possible. Where it is not possible. So let me write this down as n multiplied by E. Let me write it down as n multiplied by our E. E is nothing but 1.6 10 to the power minus 19. So that is what I'm writing 2 into 10 to the power minus 19 as. As you can very easily see, this number and this number just got cancelled. So if I have to find the value of n, so what will that n be equal to? 2 is as it is. This 1.6 will come below. Is this number going to be an integer? Is this number going to be an integer? Yes or no, guys? Will this be an integer? No, this is not an integer. Integer means like whole numbers 1, 2, 3, 4, 5, 6, like that. Not an integer. So that means this is not possible. So this is basically not possible. This is impossible. You can never have this much amount of charge. Yes. 1 and 2 are possible. No, 1 is not possible, Nisha. I just proved it to you because 2 by 1.6 is not a pure number like 1, 2, 3, 4. It will be some decimal value. It will be some decimal value. Correct? Agree, Nisha? Yeah, because if it was 2 by 1, 2 by 1 is 2, then it was possible. Correct? So 2 by 1.6 will be a decimal number, so it is not possible. N has to be an integer, like this whole numbers 1, 2, 3, 4, 5, 6. Is this absolutely clear, everyone? Nisha, Lahuti, everyone, Harini, perfect. Okay, let's try to do the next one. This one, where we have 4.8 10 to the power minus 19 is equal to n multiplied by whatever that e value is, 1.6 10 to the power minus 19. So let's see what cancels out. This 10 to the power minus 19, 10 to the power minus 19 will cancel. So what will I get the value of n as? So 4.8 over here as it is, whole thing divided by 1.6. So can I write n as 48 by 16? 48 divided by 16. I can shift the decimal by one place over here. Then the decimal over here in the denominator will also shift by one place. I can do that both in the numerator and denominator together. Is 16 and 48 divisible with each other? Is 16 and 48 divisible with each other? Yes, 3 times, right? So will I get the number 3? Yes. And this is a whole number. So 100% this is possible. This is possible because I will get 3. N is 3. So there are 3 e's over here. So I can also look at it as this is nothing but 3 times of e. So there are 3 e's over here. It is an integer. Okay, let's look at this now. 1.6 10 to the power minus 20, guys. 1.6 10 to the power minus 20. Okay, is equal to n multiplied by the value of e, which is 1.6 into 10 to the power negative 20. Okay, now as I can see very clearly, this number and this number just got cancelled. Oh, sorry, guys, this was not minus 20, this was minus 19, my bad. Sorry, minus 19. Okay, so I want the value of n, right? So this is n. So I will take 10 to the power minus 20 here. When this goes on the other side, what will it become? What will this 10 to the power minus 19 on the other side become? It will become 10 to the power plus 19. Is that right? When it goes on to the other side, it will become plus 19. That's how powers work. Okay. So what is the value of n that you are getting, my dear students? Minus 20 and 19. What will that answer be? It will be 10 to the power minus 1. So what is the value of n? 10 to the power minus 1. What does it mean? What does it mean? 1 by 10. 1 by 10 is not an integer. 1 by 10 is not an integer. Correct? So what will happen? This is not possible. This is not possible. Everybody with me? Example number 3 is not possible. Yep. Everyone? Very good. Till this point, absolutely clear. Perfect, perfect, perfect. How about this number? Let's try it out, okay? 8 multiplied by 10 to the power negative 15 is equal to, I do not know the value of n, and I will multiply it by 1.6 10 to the power minus 19, which you have to remember always. Okay, so I want the value of n. All right. So I will do one thing. I will take that number 8 and that number 1.6, divide it with each other, and we will have 10 to the power minus 15 as it is. This minus 19 will go on to the other side as 10 to the power plus 19. Everybody fine till this point? Minus 19 on the other side will become positive 19. Okay, now let's be careful while doing the calculations. So this will be n. Okay. What is this? 8 by 1.6. I can shift the decimal by one place. It will be 80 by 16. I shift the decimal by one place. So there was no decimal here. So think of it as 8 point. So if the decimal shifts by one place, it will become 80. So if the decimal shifts by one place, what will it become? The number 80. Everybody gets this? Actually, this was 8, but 8 I can write it as 8.0. So you shift the decimal. So it will become the number 80. And what is this? This is becoming 10 to the power 4. This is becoming 10 to the power 4, guys. 16 and 80 cancels with each other how many times? 5 times. 16 5s are 80. So what is the value of n that I'm getting? What is the value of n that I'm getting? I'm getting the value of n as 5 and 4 zeros. 1, 2, 3 and 4. Is this an integer? Yes, it is an integer. Yes, it is an integer. That means 100% this is possible. This is possible. Is this absolutely clear? Yep. Perfect. Understood how to solve these questions? So they can also ask how many electrons or how many protons are there. So this number n is exactly that number of protons or electrons in every example. Yeah, this is the number of E's which are there. So this has 3 E's. This one over here has how much? 50,000 of those E's. 50,000 of those E's. So definitely it is possible. That's how you solve the questions, my dear students. Okay, let's take an example coming up on your screen. If a charge on the body is 1 Nc, then how many electrons are present on the body? Now you should know these these prefixes: nano, pico, micro, milli, etc. If you do not know them, let me remind them for all of you. For example, you have m, then you have mu, then you have n, then you have p, and then you have f. This is basically called as milli. Everything is small letters. This is micro, this is nano, this is pico, this is fermi or femto, whatever you want to call it. So this is 10 to the power negative 3. This is 10 to the power negative 6. This is 10 to the power minus 9. This is 10 to the power minus 12. This is 10 to the power minus 15. You increment it by powers of 3. 3, 6, 9, 12, 15, like that. Okay? These are all small alphabets. But when you put big alphabets, capital K, capital M, capital G, capital T, this is basically kilo, this is basically mega, this is basically giga, this is basically tera. Okay, so what are these multiples? Kilo is 10 to the power positive 3, this is 10 to the power positive 6, this is 10 to the power positive 9, and this is 10 to the power positive 12. So again, 3, 6, 9, 12, multiples of 3. These are small alphabets, so negative powers, big alphabets, positive powers. Okay, clear till this point? So let's go to this problem. When you see 1 nano coulomb, what comes to your mind? 1 nano coulomb is nothing but 1 nano is 10 to the power minus 9. So 10 to the power minus 9 coulomb. That is the charge which is there on that. How many electrons are there? So can I say basically 1 into 10 to the power 9 means 10 to the power minus 9 only is equal to n multiplied by e again, n multiplied by e again. So what is that value of e? It is 1.6 into 10 to the power minus 19. Using charge quantization, nothing. Q is equal to ne. Q is equal to ne. That's all I'm using. Charge is number of charges, electrons, protons, whatever, into electron charge, which is 1.6 10 to the power minus 19. Let's see what is the value of n that I get. So this value of n will be nothing but 10 to the power minus 19, the whole thing divided by 1.6 into 10 to the power, sorry, not minus 9, this was minus 9, my bad. This was minus 9 and this was basically 10 to the power minus 19. Is that right? If you want 10 to the power minus 19, I can take it on the top. So this will exactly become 10 to the power minus 9, whole thing divided by this 1.6 stays as it is. This will become 10 to the power plus 19 when it goes on the top. This is positive 19, this is minus 9. So 19 minus 9 is nothing but 10. So therefore, this will just become 10 to the power 10 whole thing divided by basically 1.6. If you want, you can just write it down little bit better like this: 10 multiplied by, or let's say 100 multiplied by 10 to the power 8, because 100 is 2 powers of 10 and 2 and 8 becomes 10. The whole thing divided by 16. Why did I do that? Because I can divide it easily. I can divide it easily. So just do that division on the sideline. 16 and basically 100. How much will it be? 100 divided by 16. Deliberately I did it. Deliberately I took that 100 separate because I can then divide it very easily. Oh, sorry, it was 1.6. No, my bad, my bad, my bad, my bad, my bad. Sorry, guys. Sorry, sorry, sorry. My bad. It was 1.6. My bad. So this I can write it as 10 by 1.6 into 10 to the power 9. If I take 1 0, then it will be 10 to the power 9. This I can further write it as 100 by 16 into 10 to the power 9. 100 by 16 into 10 to the power 9. This decimal place, I shift it. So this decimal which was invisible, I will have to shift it. So it will become 100. That's all I have done. Is that fine? Now it is easily divisible. I can just divide it by 100. How much will it come out to be, guys? 16. 16 5s are 80, 16 6s are 96. Come on, guys. You already know the answer now. Yep. Decimal has come. Decimal has come. Then 0. This will be 5. 6.25. Yes. So the answer for this will be nothing but 6.25 into 10 to the power 9. That many number. 6.25 into 10 to the power 9, which is B option. Is this absolutely clear how we did the mathematics calculation? Everyone? Pakka? No, no, no. When it is negative power of 10, who is that? Selvarani. Selvarani, where did it go? This one, right? This 10 to the power minus 1 is, you have to take that value. You cannot say, then though anything I can say it is not an integer. Or I can say it is an integer. So if I write 1 into 10 to the power minus 1, is it an integer? No, definitely not. This is nothing but 1 into 1 by 10, which is basically 0.1, which is definitely not equal to 1, 2, 3, 4, none of this. So 100% this is not an integer. Cool? Got it? Selvarani? Perfect? Yes, awesome, awesome. Let's just go ahead and solve the next part of it. Now, when we talk about, okay, bodies which are charged, I just told you some time back over here, either a body can be, where did it go? I told a body can be positively charged or negatively charged, and that positive charge means more positives than negatives, or negatively charged means more negatives than positives. That's what I told you. But how do you charge it? There are multiple ways. So you should just have an idea about it. How do you charge, bodies by multiple ways? But before that, a clear information about conductors versus insulators. What is a conductor? A conductor is a body which has free electrons for conduction of electricity. For conduction of electricity. Example: gold, aluminium, copper. These are all basically all the metals. Most of the metals are good conductors of electricity. So there are free electrons available. They can easily spread, they can easily mobilize themselves and conduct the electricity. Those are conductors. So what about insulators? They don't have free electrons. They can't mobilize the charges. They can't mobilize the charges for conducting electricity, for conducting electricity, and examples of them like rubber. If you connect it to a wire, it will not conduct electricity. Wood, it will not conduct electricity, right? All these plastic, all these are bad conductors of electricity. So many examples are there. Yeah. So conductors, they can allow the charges to flow. Insulators, they don't allow the charges to flow through them, like wood, plastic, they don't allow. Whereas copper, aluminum, iron, steel, all these gold, silver, they allow charges to flow within themselves. So they are conductors. Till this point, absolutely clear. Duration of the session will be around till 10 o'clock, 10:15. Okay. So 12th standard classes around 2 hours, 11th standard 1.5 to 2 hours. Okay. We have kept that deliberately because 12th standard portions will be very intense and heavy. So that's why we might have to sometimes take it beyond slightly 2 hours. Now, how can you charge any bodies? One is by friction, second is by conduction, third is by induction. Now, this conduction method is only valid for conductors, whereas friction and induction, you can see, you can do it both for conductors and for insulators. Both you can do. So, first, let me tell you what is the meaning of all these things. Friction. You rub something against something, you will see one body will develop positive charge, one body will develop negative charge. So, say for example, you have one body over here and you have another body over here. You rub them, okay? You're basically moving these bodies against each other. So you rub them, and after some time, you notice these bodies. You notice these bodies. You would have seen maybe one of that body might get some kind of positive charge, and the other body will get an exact amount of negative charge. So when I say one body got positive, another body got negative, what does it mean? The electrons have jumped from where to where? From orange to the yellow. So you would have seen that the electrons would have jumped from here to here. That is why wherever they ditched, there it will be positive because less electrons will be there. Wherever they came, there is excess. So it has become negative charge. So when you rub something, so one body will tend to attract the electrons and other will not try to attract those electrons so much. So one will become positive, one will become negatively charged. This is by rubbing. Okay, this is by rubbing. Yeah, I will show you this example also. Look at this. Where is it? Yeah, I have some simulations out here. And check this out. This guy over here. Okay. And this happens with all of you many times, where you suddenly touch something and you feel like a shock. Have you felt it when you shake hands or you touch a doorknob? You get a sudden shock and you're like, what just happened? That sound also comes. Yeah. So this guy over here, he is wearing some rubber boots or plastic boots, and there is a carpet. There are two different materials. When he walks on that carpet, there is rubbing action happening. Can you see? Because of that rubbing action, you can see one charge got accumulated on his body. Yeah, human body is like a conductor because we feel the electric shock. That means we can allow the electricity to pass within our body. Okay, so humans are not very good conductors, not very bad conductors also, but decent conductors, you can say. Okay, so the charge has got inside the body by rubbing action. Everybody clear till this point? Everybody clear with this example? So rubbing action is causing one to become negative. So the carpet's charge will be positive. So if human body becomes negative, carpet will become positively charged. Perfect. Okay. Now comes the next example, conduction. So in conduction, what happens? You need a physical touch. So in conduction, touching is required. So touching of conductors is required. Touching of conductors is required. So say for example, this is one body over here and you touch it and then you release it to another body. So these are two conductors like this. They touch each other over here, and now they are separate. So this is the part where they touch. Initially, let's say this had some positive charge. This had no charge at all. This is for now neutral. This is for now neutral. You bring these bodies together, you will see, the charges will get distributed. And because the spheres are equal in sizes, the charges will get distributed equally. There will be two positives here and two positives here. So they will get distributed. So charges are conserved, four positives. Here also totally four positives are there. So this happens because of the touching action. Now, when you actually touch, yes, two positives have jumped from here to here. Two positives have actually jumped from here to here. So that this becomes two positive, this remains as two positive. But actually, do the positives jump? No. Actually, only the electrons can move. So technically, what would have happened is, the electrons from here and here, this would have gone here, this would have gone here. A negative charge with a positive charge will neutralize it. There is a deficiency of electron. So electrons are less by 2 in number. That's why it becomes positive. So 2 electrons are now deficient. Deficiency means there is less number of electrons. So electrons are deficient and two electrons neutralized these two positive. So the other two positives still remain. Positives never move. It is the electrons which always move. So this is conduction because they touched, they were conductors, the electricity conducted, the charges are moving within the bodies of the conductor. Charges are moving within the bodies of the conductor. Everybody, I'll show you the example for this. Human body, a decent conductor. This metallic knob, is it also a conductor? This metallic knob, is it also a conductor? Yes. So what will happen if this person, instead of putting his nose in the finger, if he touches the doorknob, what do you think should happen? One body is charged, the doorknob has no charge. Just like our example here, charge, no charge. Immediately the charges will flow. Immediately the charges will flow. So what will happen? He removes the finger from his nose and he touches. See, zoop, those charges went. So there is a conduction which is happening and that is charging via conduction. Is this absolutely clear? Yep. Yes, Krish, I will be the mentor guide for the DNA batch. Few classes I'll be taking. The second class will be taken by our other teacher. And no, it is not Sneha ma'am. I will introduce that second teacher tomorrow. Okay. So I will let you know everything. Yes. All right. Hello, Harni. Welcome. So is this clear? Charging by conduction. Last one is charging via induction. This can happen for conductors or insulators, anything, doesn't matter. So say for example, we have a body over here. This is some body, doesn't matter. Either a conductor or an insulator, doesn't really matter. Now, it is completely free. It is completely free. So it is a free conductor or an insulator or an insulator. Now, what happens is, this is very, very important. Is DNA an online batch? Yes, DNA is online batch. Gopika ma'am will also be there for some lectures. Baswa sir will be there for some lectures. And our third teacher will, Vishakha ma'am, who is our offline teacher in Pune Center. She will be training you for the remaining chapters. So, three of the teachers will be completing the biology syllabus. Okay? Yes. Because the syllabus is huge, time is less. Simple, guys. This is a free insulator. It is not charged at all. Now, what happens is, imagine you bring some charge beside it, some, let's say, positive charge or negative charge. In the next example, I will bring the negative charge beside it. The next example, Let's say I will bring some kind of negative charge beside it. What will happen now? Now, a free conductor or an insulator basically has equal number of positives and negatives, right? And let's say these are the positives and an equal number of negatives. They are all coinciding at the same place. So it is a neutral body. It has no charge as whole. Now also no charge will be there. But what will happen is, because this is positive, what will happen is, this is very, very important, guys. I will show it exactly at the same places so that you understand it. These electrons which are there, these negative charges, those are red lines, they love positive. So what will they do? They will try to come close. So you will see more electrons. One, two, three, four. How many? One, two, three, four, five, six, seven. Seven were there. One, two, three, four, five, six, seven. Do you see the electrons are coming more towards this side? So this side becomes more negative, whereas this other side becomes more positive. So the body gets polarized. So now this is said to be polarized. Polarized means you have created a difference of opinion. One side became positive, one side became negative. It's like you are making two people fight or two groups of people fight. So you're polarizing them. You're making them, having difference of opinion. So one side negative, one side positive. If you bring negative, what will happen? If you bring negative, what will happen? The electrons don't like that negative charge. So they will try to run away. One, two, three, four, five, six, and seven. So they are running away. This side will become negatively charged and this side will become positively charged. This is also polarized, by the way. Okay. So this is also polarized again, but in a different way. This is also polarized in a different way. Is this absolutely clear? Everyone with me? Okay. So do I take in offline Vedantu? No, Swarna, I only teach in online, not in offline. Because where and all you want me to teach, already my throat is gone. Okay. So already I'm teaching on J and NEET English, J batches, Sigma batch, which is our online batch, and NEET batch, which is our DNA batch, plus some other batches. So many things are already there. So yeah, don't expect me to be in offline also now. That's it. Okay. So I'll show you that example of induction. Guys. I'll show you that example of induction. I have an example over here only. See this balloon example I have. I'll show it to you. Okay. It is very lovely. Can you see positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative? This balloon has neutral charge. This wall has neutral charge. This cloth has neutral charge. Okay. Perfect. What I will do, I'll take this balloon by rubbing action. Rub, 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 rub. What happened? Because of the rubbing action, the electrons jumped from here. I'll show it to you again. See, the moment I rub, these blue electrons they jumped onto the balloon. So the balloon is now negative. The cloth, the t-shirt is now positively charged. Agree? I can rub more, it will become more negatively charged. The cloth will become positively charged. Everybody fine till this point? This was the first method, rubbing by friction and charging the bodies. Now let's perform induction. How? See, I'll take this negative charge and I will bring it close to the wall. Will the electrons, oh, what happened? Will the electrons over here like this negative charge? No, right? They will run away from it. See how they run away. Can you see how they're running away? Can you see how they're running away? So this side became positive, this side became negative. Left side is positive, right side is negative. You can see now it is perfectly fine. It is free. The moment I bring them close, they are running away. Are you able to see that, everyone? Are you able to see that how those blue negative charges are running away? So you don't have to touch in induction. So induce means, you are without touching creating a polarization. So you are not even touching over here. So without touch. Yeah. So in case of induction, my dear students, in case of induction, without without touching, without touching, charges equal and opposite are induced, are basically induced. So one side becomes negative, other side becomes positive. So this is induced negative, this is induced positive, this is induced positive, this is induced negative. Got it now? Are you loving the way we are explaining things, loving the way we are teaching, loving the way we are conducting the classes? Are you able to understand the concepts? Because there is no point just doing things without understanding. Many people will just try to do everything within 2 hours. Can you complete electrostatics chapter in 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours? No. It takes many classes. As you can see, we are going in proper detailed manner so that everybody will understand. Okay. Perfect. So these are the different ways by which you can charge the body. So there was one question which was there, and it is so and so like this. When a glass rod is rubbed with a silk cloth, the charges appear on both of them. This is there in NCERT, by the way. A similar phenomena is also observed with many other pairs of bodies. Explain how this is observation is consistent with the law of conservation of charge. So when you take a glass rod and rub with a cloth, charges appear on both. So you might feel, sir, from nothing I have created a charge. But actually it is not so. See, if you have a rod and let's say this is that silk cloth and now you rub it, then let's say for example, this particular rod gets positive charge, then this cloth will get equal amount of negative charge. If you count the total charge before, the total charge before, the total charge before, it was a big fat 0. If you ask me what is the total charge later, that is also positive 3 and negative 3, which is also again 0. So the total charge is still conserved. It is just that the charges get transferred from one body to other. It is not that net charge is not considered or new charges are getting created. In fact, equal amounts of positive and negative are getting created, which end up cancelling each other. So the total charge is definitely conserved. Is this absolutely clear? Very good. Excellent. Excellent. Perfect. Now, let us come to the main law, which is the Coulomb's law. Yes, we have the Coulomb's law. So let's understand what is this Coulomb's law. Coulomb's law. Coulomb performed this experiment with multiple charges. He took, let's say, a charge here, Q1. He took another charge, let's say, Q2. And there was some distance between them, let's say R. So R is the separation between the charges, separation between the charges. He found that the charges, if they are like, they will repel, opposites, they will attract. So he first of all said that if they are like charges, so like charges repel each other and opposite charges, one positive, one negative, opposites attract, opposite charges attract. And when they attract or repel, there is a force. That force is on the line joining the charges, meaning it's not like this charge will repel this charge like this. No, it will not repel it in some weird direction, guys. It repels on this line only. Okay, on this line, or if it is attracting, it will attract on that line. So that force is along that line joining the charges. So this force I can put it F like this. So that force F of repulsion or attraction is along the line joining the charges. Number one, this was the first point. Also, he found that the force magnitude was proportional to the product of the charges. That means Q1 multiplied by Q2. He found it is proportional. If this is 2 Coulomb, 2 Coulomb, some force. 2 Coulomb, 3 Coulomb, more force. 5 Coulomb, 7 Coulomb, even more force. So the product of the charges mattered. And lastly, he also found that this force is inversely proportional, means 1 by r, but square proportional. That is why it is also called as an inverse square law. Inverse square law, because it is inversely proportional to the square of the distance between them. If you double the distance, force becomes 4 times smaller. If you triple the distance, the force becomes 9 times smaller. More distance, less force. Less distance, more force. Example like this, the one over here. Okay, everyone, pay attention, okay. Yes, where is it? Coulomb law. Yes, there you go. Here, check this out. This is Coulomb's law. Let's play this. Ha. So this is charge 1, this is charge 2. See this, there is some separation between them. You move the charges away, can you see the force is becoming lesser Newton? If you bring the charges close, it is becoming more Newton. Now, this is -4, this is +8, that's why there is attraction. But if I make the charge positive, there is repulsion. If I increase this charge, force will increase. If I reduce this charge, the force will reduce. You increase both the charges, the product will increase, the force will also increase. Bring them close, force will increase. Bring them far, inversely proportional to the square of the distance between them. Okay, so this is exactly what Coulomb found. So then what he did was he made it into one simple formula where F is now proportional to both charge 1, charge 2, and also inversely proportional to the square of the distance. But whenever you have proportionality, you can convert it into equality. To convert it into equality, what do you need to add? A constant of proportion. Yes, a constant of proportion. Everybody with me? Understood? Clear? So what is that constant of proportion? That is basically our Coulomb's constant, because who gave that law? Obviously Coulomb. So that is why it will be called as Coulomb's constant. So that constant was K, which is now you can rewrite this formula. F is equal to K Q1 Q2 divided by R square. K Q1 Q2 divided by R square. So this K, this particular K, is nothing but your Coulomb's constant. Coulomb's constant. And this value is found out to be 9 multiplied by 10 to the power 9. Very easy to remember. 9 into 10 to the power 9. Units are Newton meter square per Coulomb square. Newton meter square plus per Coulomb square. Is this absolutely clear, my dear students? This is the value of the Coulomb constant K. Now you will later on see that this K will be also written down as 1 by 4 pi epsilon naught. This value of the Coulomb constant will also be written down as 1 by 4 pi epsilon naught, where this epsilon naught is called as the permittivity of vacuum. Permittivity of vacuum. You will see later on that, not right now, later on in the next few classes, that the force will change when the medium changes. So right now our medium is air or vacuum, where there is absolutely nothing or very little things. Like air is almost like nothing. That's perfectly fine. So then we use that epsilon naught, which is called as permittivity of vacuum. Okay. What is the value? You can easily find it out, because I can write this as 9 multiplied by 10 to the power 9 is 1 divided by 4 multiplied by pi. Pi is 3.142 multiplied by epsilon naught over here. Okay. So now if I write epsilon naught here, it will be 1 divided by all these numbers. 4 multiplied by 3.142, epsilon naught gone on the top, 9 into 10 to the power 9 coming over here. When you solve this, it comes out approximately 8.85 into 10 to the power minus 12. 8.85 10 to the power minus 12. Units are exactly opposite. It is Coulomb square by Newton meter square. Exactly opposite of this. Coulomb square per Newton meter square. So shall I remember these values? Definitely, of course. So this value you should remember this. Okay. Even this value you should remember this. Coulomb's constant, which is 1 by 4 pi epsilon naught 9 into 10 to the power 9. So this is your formula for finding the force. Formula for finding the force. Everybody with me on this? Cool. Now, going ahead, you might have seen there is a vector form also. We will talk about it rather than going with the exact textbook diagram. I will show it to you in a very simple way. Say guys, say for example, there are two charges. Let's say there is a charge 1 over here. There is a charge 2 over here. Okay. Charge 1 and charge 2 over here. And I am interested how much force is acting on the second charge because of the first charge. So I will label it as force which is acting on 2 because of 1. But somebody will say, sir, I want to find the force which is acting on 1 because of 2. Don't have to worry guys so much. I mean, the force on 1 because of 2 will be just the opposite of the force on 2 because of 1. If this guy applies 5 Newton force here, this guy will apply 5 Newton force this side. Simple, everyone? Yeah, equal and opposite. Always. Doesn't matter whether it is repulsion or attraction, it will be, equal and opposite. Is this absolutely clear? Everyone with me on this? Perfect. Awesome. Awesome. Now, I am interested what is this vector. I am interested in what is this particular vector quantity. See, I'll tell you what. You just mark the distance between them as a vector R21. Now, what is this R21, sir? R21 is nothing but the position of 2 with respect to 1. Position of 2 with respect to 1 means something like this. If this is charge number 2, this is charge number 1. So position of 2 with respect to 1 means this arrow mark. So from 1's perspective, where is 2? So that is basically R21, because I want force on 2 because of 1. So you write position of 2 because of 1. That's it. Now, what is this R21? You would have studied this in kinematics, 3D, 2D, basically the basic kinematics chapter. You would have studied this, that any position vector R21 or V21 or A21 is A2 minus A1, V2 minus V1, R2 minus R1. So it is nothing but position of 2 minus position of 1. So what is this basically? What is this R2 that I'm talking about and R1 that I'm talking about? So R2 means position of 2, and this is basically position of 1. That's it. This is position of 2. This is position of 1. With respect to whom? With respect to the origin. With respect to our origin. As simple as that. So it is R2 minus R1. As simple as that. Very, very easy. So these are some few things which you should know before we go ahead. Now, usually they might give you R2, R1, etc. And they might ask you what is R21 for the further part of the problem. So if that is the case, say for example, point number 1 has the coordinate 3 I cap minus 2 j cap plus k cap. And point number 2 has the coordinate I cap plus j cap minus 3k cap. Chumma, I have taken some example. So what will be R21? R21, what will it be? Just R2 minus R1. R2 is nothing but I cap plus j cap minus 3k cap minus 3 I cap minus 2j cap plus k cap. So when you subtract the two, what will you get? I minus 3I is nothing but minus 2I cap. J, check this out. If you are confused, this is basically j cap over here. Minus minus is plus. Minus minus is basically going to be plus. So minus minus will basically become plus. So 1 plus 2 is 3. So it will basically become 3j cap. 3j cap. J cap minus minus is plus. So 2j cap is 3j cap. Minus 3k minus k will become minus 4k cap. Minus k cap minus 3k cap will become minus 4k cap. This is position vector of 2 with respect to 1. Is this absolutely clear, everyone? If they ask you what is the actual distance between them, that is the mod value. So mod value, when that mod value comes, that is basically the separation between them will be the modulus of it. And whenever you have to find modulus, you take the root of the squares of the components. That's all. So it will be 2 square, 3 square, don't worry about these signs, and 4 square. That's all. That is the separation between them. So how much will it come out to be? Just check it out. 2 square is nothing but 4, 3 square is 9, 4 square is 16. 16 plus 4 is 20, 20 plus 9 is 29. So root 29 is the distance between those two particles. Root 29 is the distance between those two particles. Everyone understood how to find this out? Absolutely clear? Absolutely clear? Everyone? Not root 26, man. Money. Ayo, why are you saying root 26? 2 square is 4, 3 square is 9, 4 square is 16. 16 plus 4 is 20, 20 plus 9 is 29, no? Okay, I think somebody made a mistake and yeah. Hi Bhavitra. Yeah, welcome everyone. Yeah, perfect. So these are the things that you should know. Now, once this is done, the force value F21, magnitude wise, I already know it. It is nothing but Coulomb constant, charge 1, charge 2 divided by the distance between them, which is R21, whatever it is, the whole square. But if I want the vector F21 bar, it is the magnitude, which is F21, whatever it is, the magnitude, and there is a unit vector in that direction. Very, very important. A unit vector in that direction. Vector is the magnitude into unit vector. That unit vector will be R21 hat. And unit vector is always the vector divided by the magnitude. So you can just put F21 and R21 hat if you want. That's it. That is the answer. Okay. So if you want, you can further simplify it and write. Never in my career I have seen NEET problems or JEE problems requiring this. Chumma NCERT has wasted and killed a lot of time of students. So this will be K Q1 Q2 divided by R21 square, and you can just put R21 hat, which gives the direction of that force. This is magnitude part, this is direction part. So this gives me the direction. This particular part gives me the magnitude, and magnitude with the direction will obviously give me the vector force, the force vector. The force vector is the magnitude times the direction. That's it. That is the thing which you should be aware of. Is this clear? So very, very important. This, including this over here. Okay, cool. Yeah. Is there any time change in the timing of the sessions? Which sessions are you talking about, Ananda? DNA batch? Yes, DNA batch. We are just keeping some more classes in the evening rather than in just in the morning, because many students wanted some evening classes. We are just trying to change and bring as many things in the afternoon and the evening times. So as much as possible. Okay. All right. Now this was the force part. So let me just show you some questions on this. Yeah, some two questions will solve, and superposition, very simple, we'll solve that question and then we will call it off a day. Okay. Acceleration of an electron due to attraction between electron and a proton when they are 1.6 Armstrong. Armstrong is 10 to the power minus 10. Huh? Armstrong is 10 to the power negative 10 is how much? Mass is given, charge is given, and the value of 1 by 4 pi epsilon naught is also given to us. Okay, let's understand this problem. So there is a positive charge and there is a negative charge. There is a distance between them, which is 1.6 into 10 to the power negative 10 meters. What will happen to them, guys? They will attract each other, yes or no? Because one is positive, one is negative. So there will be a force F on them. But because of that force, there will be acceleration. So 100% this electron will accelerate. If you ask me, how is force related to acceleration? We all know that the force is mass into acceleration. So if I find force, my job is done. Is that right? Yes. So we all know the force is nothing but the mass of that electron multiplied by the acceleration. This was your Newton's law of motion, which you have studied back in 11th standard or 9th standard and 10th standard also. So we want to find A, we need to find force also. What is the value of force? It is Coulomb constant into charge 1. What is the value of charge 1? It is basically E. Magnitude of the other charge is also E. We are just interested in the magnitude. We are not interested in the actual value of the acceleration. We are just interested in the magnitude. So E divided by E divided by the distance square. This is equal to the mass times the magnitude of the acceleration. Do you understand why we did not take negative E? Because we are only interested in the magnitude of the acceleration. That's all. Okay. So what will be the acceleration? Acceleration will be, as you can see, m will go down. So it will become k multiplied by e into e is e square. R into r square is there anyways. And this mass will come down over here. Now start substituting everything. Value of k, Coulomb constant is 9 into 10 to the power 9. E value is 1.6 into 10 to the power minus 19. So 10 to the power minus 19 also will be squared. Is that right? E squared. E is 1.6, 10 to the power minus 19. So I'm squaring both. The whole thing divided by R. R is nothing but, again, this. If you did not understand what I've done over here, 1.6, 10 to the power minus 19. This thing is squared. Okay. R square is 1.6 into 10 to the power minus 10. This is also squared. And last thing is the mass value, which is 9 into 10 to the power minus 31. Okay. Few things will definitely cancel. Like for example, I'll tell you this 9 and this 9. 1.6 squared and 1.6 squared will also get cancelled. So I will be left with, observe this carefully, this power of 10 raised to 9 minus 19 raised to 2. So this will become minus 38, I believe. Whole thing divided by minus 10 raised to 2, so minus 20. And over here, minus 31. That is what will be there. Come on, now do this math and tell me what is the answer. Come on, guys, do this math and tell me what is the answer. Everyone, it's not that difficult. Minus 20 minus 31. So first of all, take care of the upper powers, right? So this will become 10 to the power 38 minus 9 is minus 29. So this is minus 29. And this over here is nothing but 10 to the power minus 51. So take it on the top. So 10 raised to 51 multiplied by 10 raised to minus 29, which will become nothing but 10 to the power 22 meters per second square. 10 to the power 22 meters per second square, which is C option. Got it? How we solve this particular question? Very good, very good, very good. So this kind of question was asked in NEET 2020. Okay, this kind of question was asked in NEET 2020. With practice, you will get, the hang of it. Very good. Let's go to the last part of today's lecture, and that is basically force between multiple charges, which is also called as the superpositioning. Superpositioning. This is very, very important. Say you have multiple charges Q1, Q2, Q3. Everyone will apply force on everyone. So you take any charge, you will see, that will experience force by every other charge around it. Yes, it will experience force because of every other charge around it. So say for example, this particular charge is there Q1, another charge is there Q2, another charge is there Q3, another charge is there, for example, Q4. You will notice, if you are concentrating on charge number 4, charge 2, charge 1, and even charge 3, all of them will apply force. Yes, all of them will apply force. For example, charge 3 might be attractive because they are opposite. Maybe charge 1 is repulsive because they are equal signs. Maybe charge 2 is again repulsive because they are opposite, or sorry, equal signs. So these are the forces which will be acting on each due to each charge on this guy. So the net force on the number 4 due to 1, 2, and 3 is given by, okay, this is very, very important, that net force on the charge numbered 4 will be given by force due to charge 1 on 4 plus force due to charge 2 on 4 plus force due to charge number 3 on 4. You add all these numbers, you will get the net force. You get all these numbers, you will get the net force on it. Okay, each value can be calculated separately. Each value can be calculated separately. Let me demonstrate an example for this. Like over here also you can see there is a charge 1 here. Charge 2 will apply some force, charge 3 will apply some force, charge 4 will apply some force. All together will give you the net force. Let me give you a simple example for this. Very, very important. Observe this now, okay? Imagine there is a triangle like so. Side length is A. This is the last example. This is also A. Imagine this charge is Q. This charge is negative Q. And this charge is capital Q. And the question is, find the force on capital Q. Find the force on capital Q. That is the question. Okay, find the force on capital Q. So what will we do? we will think other charges will still apply force on this guy. Doesn't matter how many charges are there, each pair of charges will apply their repulsive or attractive force. For example, this positive and this positive will repel each other, correct? They will repel each other. Whereas this is negative, this is positive, so they will attract each other like this. Oh, these are the forces. Sir, what is the value of these forces, sir? Well, K, Coulomb constant, Q1, Q2, that means capital Q, small q, divided by distance square, means A square. Sir, what is the value of this force? Coulomb constant, charge 1, charge 2, divided by the separation square. Oh, these are the two forces. But is it the resultant or the net force? No, you have to use vector formula. You have to use vector formula, guys. Yes, vector formula. So when you have two forces, two vectors which need to be added, what do? You have one vector here and let's say one vector here, and you have to find the net vector over here. What is it that you do? That net is given by, do you remember that formula, guys? Do you remember that formula? A square plus B square, or F1 square plus F2 square, plus 2 times F1 F2 cos theta, where theta is the total angle between the forces. Theta is the total angle between the forces. This was the formula which you have learned in vectors chapter. So that's all you need to do. So the net force will be root of F1 square, F2 square. If you notice, both the numbers are same only. Anyways, we will write it down as it is. It will be KQQ divided by A square square plus KQQ divided by A square. Actually, writing them again and again is a painful task. So, I have an idea over here, writing them again and again, because value wise they are the same. So why not write them as some small f, this also as small f. It will be easier for me to solve. And how much will this angle be? How much will this angle be? Can you guys quickly think and tell me? Because I know this angle will be 60 degrees. So the remaining will be 180 minus 60. So the remaining will be 180 minus 60, which is 120 degrees. Which is 120 degrees. Everyone till this point absolutely clear? Okay. So let's see what do we get. F1 is just assumed to be F. F2 is also the same value magnitude wise F, plus 2 times F into cos of 120 degrees. So what does this become? F square is there everywhere. So root of F square is there, common, 1 plus 1 plus 2 times of cos of 120 degrees. Okay. Root of F square is just F. Take it outside. 1 plus 1 is 2 plus 2 multiplied by cos of 120 degrees. Okay. Next step. F as it is, 2 plus 2 into cos 120. What is the value of cos 120? Standard value, negative half. Negative half. As soon as you see that, this 2 and this 2 will cancel out. So what will be remaining, my dear students? F is there as it is, 2 minus 1, which is nothing but just 1. Root of 1 is just the number 1, which is just F then. So that means the answer will be KQQ divided by A square. That is the answer. KQQ divided by A square is the net force acting on Q. That's it. Yeah. We don't use vector form, Guru, for anything. Don't use it because it is useless. We always use vector addition formula, resolution of components and all of that. Okay. Now, I am going to give you a homework question. This is very, very important, guys. Yes, this was asked in AIMS. Very good question, but very simple also. 100% you will be able to do it. Very similar to what we have done, but read the question carefully. Okay, so this is your homework question. The answer will be there in the should be there in the comments. Answer should be there in the comments. Next lecture, I'm going to open up the comments in the live section and I'm going to see how many of you have done it sincerely. Okay, so read the question. What is the force by the charge placed at the vertex A in a direction normal to BC? BC is this. What is normal to BC? Normal means perpendicular. That means in this direction. What is the force on this charge in this direction? Hint, take the force due to this negative charge and this positive charge, show them and see what is that component in this direction, what is that amount in that direction. Maybe you will see some magic out there. Okay, that is your big hint. The answer is there on the next slide. The PDF will be available tomorrow to download in the comments pinned message or even in the description box. So you can definitely check out the solution as well. Okay, absolutely clear, guys. So that is your homework question for today. Homework question for today. Answer it in the comments. We'll be opening it up in the live chat next time. So today we have completed, what are the charges, what are the different types of charges, the properties, three properties: quantization, conservation, addition of charges. Also, we have seen how do you charge a body: by rubbing, by conduction, by touching, or by induction without touching. Just bring them near, the charges will polarize. And then we have seen Coulomb's law, which is K Q1 Q2 by R square, Coulomb constant, and 1 by 4 pi epsilon naught. And then we have also seen when there are multiple charges, then you take all the forces together to find the net force. Okay, that is what we have seen. So I hope you enjoyed the class today. Smash that like button, mark your attendance. Next lecture will continue with the next topic, subtopic. Okay, this chapter is big, so it will take many classes. Okay, bye bye. Have a great time. Take care.